I mean, if you're on the phone, hands-free, and the speaker is talking, well, on the outside you can hear that very well, but not
Oh.
in that case when you have an enclosure. It's a different world, automotive, really.
Yeah.
Yeah.
Hey everybody, Dave Limburg in Hong Kong with another episode of the THD Podcast, probably the last one before Christmas. So have a Merry Christmas and don't forget CES is coming up. So we will be there. And if you're interested in some of the stuff I do with DB Enterprises, please be sure to reach out and make an appointment to come to our Venetian meeting suite. But today we have a company again. They're kind of, I guess, our third time with Dinaburg, or maybe the second. Doesn't matter. Dinaburg Technologies with their C2S technology. We're going to find out about how it applies to automotive applications. And we've got an expert on the line to explain and has some measurements done to show the benefits of their C2S technology in automotive. But without delay, give a shout out to the Alti Association. They'll also be at CES. We encourage people to check out the Alti. It's a great networking association related to audio manufacturing. And also Audio Express, always a shout out to Joa. He helps us out a lot, and we're always following his publications for tips on people to bring on this podcast. So the secret is out. But without delay, let's give hello to everybody. So we have Simon up late in Sendai, Japan. Good evening,
That'll be
Simon.
me. That's this Simon. Yeah.
That's that Simon. Simon
Evening, Dave.
Dynaburg in Dallas, Texas.
This will be this, Simon.
And Alfred Svobodnik with MVoid Acoustics based in Vienna. Nice to meet you, Alfred.
Hi, good to see you guys.
Okay. So yeah, Dynaburg, Simon, we're talking about your technology as it applies to automotive. So you want to give us a preface on that, and then maybe we'll get Alfred to dive into what he's discovered on his research.
Sounds good. Dave, Simon, nice to meet you again and nice to see you. Today we would like to present the work we completed in the last 6 months, which have to do with C2S implementation in automotive. All of that work was done in console. And I would like to pass the baton to the man who actually performed the work, where we can dive in presentation and just take it from the top. Alfred?
Okay, yeah. Well, then let's start here. There is an interesting background to that project. Actually, it was about I guess half a year or 8 months ago. I had a chat with Barry Vogel from Alti, and we talked about the industry and especially about innovations in industry. And when I say industry, it's specifically the automotive audio industry. And he brought up, Dinaburg technology. He said, well, this is an interesting technology. It might be something that you could really use in automotive applications. He sees a lot of benefits here. So, well, we met. Simon and I, and actually also Michael, his partner, and we were talking, and then we said, well, okay, well let's try to figure out what the C2S technology can do in an automotive application. And it was actually at the high end show this spring in Munich, when we had a little bit more time to talk to each other, and I spent some basic thoughts about C2S and how we can use it. And I said, well, I think there might be a couple of benefits, and it might really make sense to go a first step and make a proof of concept. And that is what I'd like to present here, how we did this proof of concept. We did not go into hardware for many reasons. Main reason, of course, is costs. It's very, very expensive if you build everything, because, the speakers in a car environment, they are a little bit different than you would use it in a professional or in a consumer application. So you really need an automotive version of the speakers. And the other thing is, of course, this is our specialty. We do this for a long time, actually. I started back in 1990 with simulations. So we really have expertise in doing these automotive audio simulations. So, well, I'm going to explain to you what that means, how we're going to do this. So the goal or the target was clear. I mean, we were actually building or integrating C2S speakers in an automotive environment. And the first shot, to be honest, with consumer speakers was not so good, simply because you really need to optimize these speakers for a given application. And that's, I would say, also an interesting advantage of these speakers. You have more design possibilities or changes in the speaker. So we were then, saying, well, not a single system, but maybe two systems. So a 6 and a 10 speaker system. I'm going to show that in a few minutes, what that definition is. And we were then replacing, the traditional speakers by just two types of C2S speakers. So a woofer and a full range. And that's very important. That's one thing that is extremely important in the automotive industry, because that would mean only two part numbers in a system, and a part number is a challenging topic in a car. It's pretty expensive because of all the logistics that goes behind that. And what we did then was, we built that virtually, the system. We tuned the system also virtually, and finally we were oralizing it so that we can really listen to the system. I think the listening test is the most important test case here when we're talking about the audio performance of an audio system. And I say audio performance because in a car environment, there are a couple of other requirements that are maybe not so much related to the audio performance. So the car that we used here was a virtual car that we have developed originally for training purposes. The challenge is simply, if you go to different OEMs, and these are typically our customers, you cannot use different cars, and you cannot set up a simulation model of a specific car. That would be really way too complex. So, and we wouldn't own the IP. That's the other problem if you would copy that. So that's the reason why we call it the MVoid SUV. And that's based on a mid-size SUV, basically, simplified geometry, but realistic physics. We did not really change the physics of the car cabin. In terms of its surfaces and materials that are being used, we were just simplifying the geometry. And the one purpose is to use it for training. The other purpose is to use it as a test bed for innovations, because this is a model that is available and that you can easily change, like saying, well, we want to use different speakers here. Use in that case, the C2S speakers, and then we can also go, another step and optimize the location of the speakers. But that is maybe the next thing that we're going to do. So okay. The two systems that we are looking at, is a standard entry-level system with 6 speakers. You might be laughing, but it still exists. 4 door woofers, 2 tweeters. And actually, I was a little bit shocked, when all this EV hype came up, because most of the first generation cars, they had this type of entry level system. And it does not really give a very pleasant sound, but they were, I think, happy to have a car that can drive, and then they have been maybe looking at the sound system that they use here. And then we have a premium system on the right hand side. Premium, well, that can go from 2. But that's I would say more a low-level premium system here. But you're going to find it very often on the market these days, especially with branded systems. And it's a typical 10-speaker system. So compared to the 6-speaker system, you're adding tweeters for the rear seats, you add a subwoofer in the center speaker. And this is something that really significantly improves the performance of the six speaker system. I mean, if you add the center speaker and the subwoofer in the trunk.
Mm-hmm.
So same thing with the C2S. Instead of the tweeters, we're using a C2S full range speaker. So that's in the doors and also in the center IP in the instrument panel, and then we have also the door woofers replaced by a C2S speaker, and also in the trunk we have that. And here's an interesting thing, because C2S needs a small enclosure, and that means that actually the subwoofer can really be absolutely the same speaker plus enclosure as you would use it for the door woofers. So this is not an additional part number. It's really just these two part numbers that would be then in a car. I mean, these are the malls. I don't want to go too much into details of the mall itself. I mean, you can look up lots of papers where we are describing, the technology and the research behind it, and also the accuracy and reliability of these simulations. But one thing that I would like to mention here is that we use finite elements, but we also use ray tracing, because for high frequencies, I mean, finite element method doesn't work that well. So that's the reason why we need a hybrid mall, really two different malls based on FVA and ray tracing to get the full audible bandwidth that we need, because we want to listen to the car. And that simply means we need to go from 20 hertz to 20 kilohertz here.
So am I maybe I'm ignorant here, but I'm just guessing. Ray tracing, I'm not familiar with that. Is that you're literally mapping out where the wavelengths at different frequencies are behaving as you get to a certain frequency? Is that, if I try to decipher what that means?
No, well, I mean, I would say the general or top level name is geometrical acoustics. So there is a level of simulation methods, that are relying on geometric relations. I mean, one is the source mirror method, for example, where you're mirroring the source, and the other is these ray or cone tracing methods. You trace a ray that is shoot out from a point, and then you have a reflection on a surface, and so on. And typically you go 2, 3, 4 reflections depending on the application, and then you can define a receiver that really catches these rays, and then they get the sound event at the end of the day. And then you do this with a lot of rays, shoot it out, and you include directivities and so on.
Okay, thanks.
Oh, you're welcome. And I mean, that is how the model looks like. And we can see here in the doors that there is an enclosure, so we don't have to maul the door cavity, because usually in a door woofer, couples to the door cavity. And I remember, when I started in automotive audio quite a long time ago, it was 2006. I was thinking, door cavity, that's nice, because there's a lot of volume. It's between 50 and maybe 70, 80 liters. But later I figured out, I'm not sure if it's a good idea to use the door cavity. And it's simply because of the door. A door is not designed, to act as an enclosure for a speaker. And that's part of the problem. I mean, it's weak, and you have, very thin sheet metal, goes down to 0.6, sometimes 0.5 millimeters. Rattle noise. I mean, really lot of bad things. And this is another interesting improvement here, because it decouples. You have this enclosure, so there is absolutely, less interaction with the doors in terms of, let's call it parasitic vibrations and noise that you would get here. And in some cars, I mean, it's more in luxury limousines. For example, they use enclosures in the door because of privacy. I mean, if you're on the phone, hands-free, and the speaker is talking, well, on the outside you can hear that very well, but not in that case when you have an enclosure. It's a different world, automotive, really. Yeah, and we had such projects, really.
Okay.
We had to do this, and as you can see, I mean, the same enclosure is used here in the trunk and the floor. So it's really the same geometry we can use, and the same thing here with the full ranges. They're all of the same size here. We have them in the doors and also in the IP. I mean, one thing that I mean that is long known for being a problem in a car is when you combine a woofer with a tweeter, because the woofer really has to play up quite high, and the tweeter cannot really play down. I mean, usually you have a crossover of 3-4 kilohertz, so there are already lots of breakups in the woofer. But for me, I mean, the more dramatic thing is really the change that you have in the stage. I mean, in the height of the stage, because the woofer is down low, and the tweeter is high, and that is really what you can hear in the stage. That's not the case here, because the C2S full range has quite a low crossover frequency, so 250 hertz, and this is where directional hearing typically starts. So you don't have this issue with the sound stage here.
Okay.
We're gonna have lots of curves now, and but I think it's still better to see some curves other than saying, "Hey, this sounds fantastic." Yeah, listen to it. I mean, of course it does. I'll talk about that a little bit later. But that's I would say the basic justification here. If we look at what we call the full system balance, so that means all speakers are playing, and the system has been tuned. And there's a lot of things you need to tune in a car. First, because of the resonances in the cabin that you have, but then also because of the misalignment of the speakers. So time of arrival is different, so you need to play with delays. The resonance is mainly worked out with EQ, of course, and then we need to bring all the speakers together spectrally in a reasonable way, and that is what you can see here with the green curve. So the green curve is a standard target curve that we are trying to aim with the full system. The other 6 curves here, I mean, these are the individual channels in the system, and the thick red line, that's the summation of all the speakers. And what we show here is the so-called localized sound power. That was actually invented or researched in the 80s of the last century by some engineers from Ford. I mean, they actually figured out that listening in a small room is associated with sound power and not really sound pressure, and they came up with a measurement method that is a good approximation for sound power, and it's local because that measurement is done locally for the different seating locations that you have in a car. So what we are looking at here, I mean, is the driver's seat. That is what we are going to compare. So left-hand side, MVoid transducers. I mean, the transducers, they have all been designed by us. It was not the purpose of really having good loudspeakers. I mean, we just used it for, you know, explaining our process, but also validating our process and comparing simulations with measurements. And on the right-hand side, I mean, we have the C2S system as I've shown it before. And one thing that is very obvious is the sensitivity. So it's much better. And I have to say, I mean, we did not much change the tuning parameters because you could then play around and boost things. That is not what we have done. We were actually starting, with the tuning of the MVoid system and then use that for the C2S system with some slight modifications there. So we really end up in a 4 dB boost compared to traditional speakers. And I know, I mean, sensitivity or efficiency is something that is very, very important in an automotive application. And it's very obvious, really. Also, when you make listening tests, you can hear that. And also what I have to say is, when you do the tuning, I mean, we do not only focus, here on a sound power curve that we have in our system. It's really listening. So we listen to the system, and our virtual tuning system is real time. So if we change any parameter, you can immediately hear that how it changes. Because a curve might look nice, but it might not sound nice. So that's the idea
Alfred,
behind it.
you mentioned earlier, so on the left-hand side is traditional speakers and the right-hand side is and you mentioned earlier that the high frequency, the tweeters roll off fairly early. It looks like it's caving from about 2 kilohertz. Why is that? What's different about the C2S drivers? They can go all the way down to 200. It is essentially.
I mean, they are simply much bigger. It's more. You would need to compare that with a traditional full range speaker, rather than a tweeter, and it's simply the size of the speaker. I would say why it's going down, and also the tuning that we have done. It's with the passive membrane that is integrated. It's much easier to tune the system so that it really plays down to the frequency where you need it, in that case, to cross over with the woofers.
And then the converse is the low frequency drivers are rolling off quicker. Is that on purpose? Is that by design to match with the high frequency drivers?
You mean to the low end, the C2S woofers?
Yes.
Yeah. No. I mean, this is typical because it's a passive radiator that we have there. So they have this strong roll off, and also we need to protect the speakers a little bit.
The roll off in at the high side. So the left hand side, your 4 speakers are going all the way up to about 1 kilohertz. Whereas on the on the left hand side, on the right hand side, they're rolling from say 100 or 200.
Yeah. Do you mean this here?
I don't see a mouse. Sorry.
I'm sorry, but you mean the C2S blue and green line?
Oh, there we go. Yes. Yeah.
Exactly. I got it now. Yeah. Now we actually, that is what you typically do, is you add a low pass filter to these speakers. We don't want to have them play higher. I mean, they could.
Yeah.
But you have an issue with the soundstage then, because then, the soundstage goes up and down. And that is exactly what we don't want to have. We really want to have, the voice coming only out of the full range, because then we have it high. We always like to have a high soundstage in a car. I mean, that's the reason why, if you listen to a system with 3D height speakers, even if we are not talking here about immersive or 3D surround, it is already has an interesting effect on the lift of the soundstage, and that's the reason why we do this here.
Right. It's rolled off. It's rolled off on purpose.
Yes.
Yeah.
Yes. Yeah. Yeah.
Excellent. Thanks.
And you see, in contrast to the traditional speakers, you cannot do this because the tweeter starts at 2K. So you would have a big hole. So you really need to live with the fact that, the speaker plays in a region where it's not supposed to work, really. So okay, then well, as the last slide is looking at the 10 speaker system. So this is quite similar in terms of comparing the two versions. The traditional speakers versus the C2S, very similar increase in sensitivity of 4 dB. And the other things are I would say pretty similar. In a premium system, and as I said, this is more an entry premium system. If you would have a more advanced premium system, you would actually have three-way system in the doors. Exactly what we have been talking about, Simon, because if you want to cross over the tweeters with the woofers, it would be good to have mid-ranges in between. And but that's way more expensive. You have an additional channels that you need. It's not only the speaker, it's the amplifier channel. And for the driver, quite efficient is then really to use the center speaker. You can use the center to fill up this gap here.
Yes.
And the interesting thing is, these are curves, and well, you can say, oh, it's hard to understand, how does it sound? And I fully agree with that. If you look at the FSB curve, the red curves, of course they're not flat, they're not smooth. That's the challenge of a car, and it's always not easy to understand what we can hear. If you have some wriggles in your curve, it does not really mean you can hear it. So you really need to do the listening test and say, well, okay, here we go. Well, that's the difference. So one thing is the 4 dB better, but how does it sound? And that is what we have done, of course, also finally, and say, well, it sounds good. So it's really, I would say, a super interesting technology for an automotive application.
Okay.
I would say that's it from my end.
All right. Simon Weston, any more questions?
Yeah, a couple more. So this this topic about the C2S driver running down from very high frequency, low frequency. Of course, the problem is directivity, is it not? Is it overcome that problem?
Well, directivity, that we haven't experienced that problem, to be honest, because in a car, you're almost in the near field of the speaker. And you also have this directivity issue with the tweeters, and usually what you're trying to do is what is called cross-firing. So let's say the front left tweeter is not for the front left seat. It's typically oriented for the front right seat because of that problem. Yeah.
And so you were getting a much greater bandwidth out of you're replacing the high frequency speakers with something with a much greater bandwidth then.
Yes.
Yeah. And it's a little bit small. The black curve is the rear subwoofer.
Yes. Yeah.
Yeah. Okay. And so that uh, well, that caves severely on the left-hand side from about 300 hertz. That's it. And this is just pure subwoofer. Then you're only looking to generate something very low frequency. You don't care
That's
about anything higher.
yeah, that's right. I mean the door woofers, I mean they typically roll off at 50, 60 hertz.
Mm,
I mean to the low end, and you need to apply a high pass filter here because of the rattle noise issue, and also because I mean the if you look at the pure output of a door woofer, there is a natural roll off depending on the car between 40 and 50 hertz. That is simply acoustics.
mm.
So you do not really get much below that. And that's the role of the subwoofer. You just want to fill up, the low end here, which is 40, 50 hertz. That is what you're interested in.
The left hand,
Sometimes maybe lower.
yeah, the left-hand side classical design is also using enclosures for the speaker in the doors.
No,
No, it's not. So
no,
that
no.
the door panel between the door panel and the metal is the enclosure.
Right, right,
Okay,
right.
well, that's
Yeah,
interesting.
yeah.
And so that's actually a key point then, because you have a module, right, self-contained with enclosure, and the C2S speaker is incorporating that passive radiator effect essentially, so recovering some low frequency energy.
Absolutely. And the funny thing is with the passive radiator, I mean we have been working for, I mean, really lots of premium car companies and have been designing subwoofers for them, ported systems. And, you know, all the designs that I've seen, they were wrong in terms of an automotive use. Yeah? And I said them, and that is what we found out with the simulation. The port needs to be closer to the speaker,
Mm,
but usually is not done in a car.
mm.
You really have to do that. And then I saw that C2S and was thinking, they got it. I
Yeah.
mean, that's really perfect. Yeah, that
And
is
so
what you need
if
in a car.
those if they're traditional, I'm using the word traditional, you know what I mean? If the
Yeah,
left-hand side
yeah,
speakers were
yeah.
actually given a sealed enclosure on the rear side, their low frequency output would be ruined. It would be totally destroyed, right? They're relying on the fact
Absolutely.
that they have this
Yes. Yeah,
kind of massive,
yeah.
albeit leaky or noisy volume behind them. They're actually trying to take advantage of that. So, to what extent do you think that actually uh, generates more noise, basically, and it's not the signal that you want. This,
No,
yeah,
no. You have lot of limitations because of the door. I mean, the mechanical design of the door. There are a few doors that are really good, but most of them they don't work well. It's lightweight design,
yeah,
so there's really lots of rattling. That I mean, it's not good. Yeah. And also the thing is you have a lot of uncertainties from manufacturing. That is also what we have seen. Some of the processes are not fully defined in detail, like spraying special materials on the outer sheet metal. That's done by hand, and that it varies significantly. As it's also a nightmare for a loudspeaker. So yeah.
Right.
a little bit of a tangent, if you don't mind. When I was a little bit younger, it was very common to replace your car speakers with aftermarket stuff. But now it seems like it becomes increasingly difficult because it's just there isn't that level of freedom to rip a speaker out and replace it. Do you think that's the case? Is it just because I'm old, or is that?
No, I mean you're absolutely right. I mean, in Europe, aftermarket is bad for 20 or 30 years. Still
Yeah.
alive in America,
Yeah.
I would say. And there's a little bit of business with adding speakers, but also, the OEMs, they have significantly improved their systems. The
Yes.
loudspeakers are really quite well designed and optimized for a given application. Um, I mean, of course, you can improve it with better speakers, but then you also really have to um, make modifications to some structural details
Yes.
to improve that. But then you would need to change the tuning. Well, if you have a very bad system, it might make sense. But if you have a reasonable system in your car, I think it doesn't make sense to go into the aftermarket and see what's going on and
It's
do
almost
some
like,
replacement.
yeah, it's very hard to make it better at this point. I mean, the manufacturer has to deliver a really good system. If you come along and try and
Yes.
change something, you'll probably just make it worse. It's a bit like trying to tune the engine and think that you can do better than the original manufacturer. You probably
Yes.
can't, actually. It's
Yeah.
interesting.
You're right. Yeah.
Okay.
So
All right.
but that is there's one more thing, Dave. That's a really important point, though, isn't it? Because the C2S driver comes with its own as a module, as an enclosed module, whereas that's not really an option for the classic install, the classic speaker system. Is that what I understood?
Well, I mean, sometimes, there are enclosures used for door woofers. There are a couple of cars because of the privacy reason I mentioned. But the problem is, I mean, um, you might have a challenge with the low frequencies then. I mean, depending on the size and,
Mm.
space is always an issue in a car, and usually, you start with a large volume requirement of the door woofer, like 9 liter, and then you can be lucky if you end up at 4 liter. But
Mm.
4 liter is pretty small. I mean, that really has a significant impact on the reproduction of low frequencies.
And one last question, if you don't mind, because back on
Sure.
an earlier slide, there was two different metrics. One was in millimeters and one was in inches. I think it was 165 millimeter speaker. And what was the comparison? Are we at the same diameter driver in both cases?
You mean this one here?
Yeah. These are
No, I mean I that's simply the nomenclature
yeah,
that we use, and the C2S is a 6.5 inch
well, 6.5 times
speaker, but that's
2.5.
approximately the 165.
Oh, okay.
I would
These are
say.
the
Yeah.
same size
It's the
speakers.
same
Yes, I
size.
mean, yeah, the idea was that in our MVoid car that we can replace the components. Yeah, so we
Yep.
have also been looking at the design space, so that the C2S fits into the door. We
Mm,
can really integrate that. Yeah.
nice. Thanks.
Okay. All right. So that's all good stuff. And Simon's Dinaburg's going to be at CES. So if anybody wants to find out more, I encourage people to give him a bell. We'll put his contact information below, and we'll put Alfred's information below if you're looking for an automotive acoustic consultant. So it sounds like he's your guy. So Alfred, Simon Dynaburg, thanks for joining us this evening and or your morning, wherever you are. Thanks again for joining us.
Thank you,
Thank you
David.
for hosting us, Dave.
Okay. All right, everybody. Like, subscribe, share, all that good stuff. And we'll see you on the next one. Bye bye.